Welcome again to the class here in virtual science. Today's video is going to be a little bit shorter. We've been learning about how to classify matter, and we talked about things can be pure. This is just kind of a review. Things can either be pure or they're mixtures. If they were pure, there's two basic categories: elements, which we find on the periodic table. So we can find things like pure gold, refined iron, and pure iron, pure silver, pure oxygen. And we can also have pure compounds. So compounds are two or more elements bonded together. So we can have compound like water, and it can be pure. That's what distilled water is. We can have pure salt, like what you buy in a grocery store. We could table salt. We could have other compounds that have been purified. And then if it's not pure, it's a mixture, because it's not pure. And so there were two big groups of mixtures that were the same all the way through, so that every part of the mixture looks the same, and those were homogeneous. Inside, we said they were mixtures of metals, so you would have to melt them first, mix them together, and the metals would cool and become a solid. If they were liquids or gases, they're solutions. And we said solutions are clear, light can pass through them. They're so completely blended that the particles don't scatter light. If they're not even blended all the way through, so you can see, the mixture has different parts that are heterogeneous. And we could just have a heterogeneous mixture, like in those slides we looked at yesterday, like the beans and the rice and all that stuff is mixed together. It's just, mixtures of solids come together. And then there were two special groups of heterogeneous mixtures: colloids, which have particles kind of in between the size of the solution, where they're so small light will pass through, and so big like a suspension where they settle out, and they scatter light. They're things like milk, smoke, fog, jello, whipped cream. And then we have really big particles in mixture. So we have things like the Italian salad dressing, and the particles are so big and heavy that they settle to the bottom, among water, for delta. Today's question, and then we learned about physical properties, chemical properties, physical changes, and chemical changes. We're going to just do a little review of that. Okay. First question you should answer last night or on your own was, what is a physical property? And if it's a physical property, it's something we can detect with our five senses. Things like size, you can see. That's our senses. If it's stinky, you can smell it. If it's bitter, you can taste it. If it's rough, you can feel it. Okay. Or the melting point of something, you can measure. Okay. Change one of those physical properties. So if you cut it in half and it's not as big anymore, you change the size. You change its color by painting it. Okay. It's a change in one or more of those physical properties. No new substance is produced. So like cutting, if you cut wood in half, you change the size. Notice that when it's a change, it's an ing. Okay, it's an action word because it's changing. Painting would be a physical change because you're changing the color, but the paint is still paint and the wall is still wall. Okay, you can change the color. Melting, if you melt the ice, you change its phase, but you still have water. Okay, so if I say what's the formula of the molecules in the ice, it would be H2O. What's the formula of the liquid water? Well, it's still H2O. So you don't have a new substance, you just change its phase. Okay, so those are all ing words, okay, because it's something that's actually happening when it's a change. It's a chemical property. It describes how the substance will react chemically. So we can say wood is flammable, iron will rust, silver will tarnish, metals will react with acid. These tell us how they're going to react with other things and become new substances. Okay? If We allow the wood to react and burn. It's going to turn into ashes, smoke, water vapor will be released. We allow the iron to rust. It's going to turn from pure iron to iron oxide, which is Fe2O3. Silver tarnishes. Okay, it's going to turn from the element silver into silver oxide. Okay. Metals react with acids. Usually they produce salt. And what is a chemical change? When a chemical reaction actually happens. So we said up here the iron would rust. That describes its chemical property. We say the iron is rusting, and it's actually happening. But the silver is tarnishing. That means the reaction is actually happening. It's changing. The metal is reacting with acid. So again, with physical changes, we had action words, and with chemical changes, we have action words ing. Okay, so I put on here just kind of with yourself. Changes are ing. Okay, something is happening. And yesterday we learned about the law of conservation of mass. We said no matter what happens, even if this silver reacts, okay, and it rusts, the mass of the iron plus the mass of the oxygen that gets added to it when it becomes iron oxide is equal to the mass of the oxygen before the reaction. Or if we burn the wood, okay, if we found the mass of the log before the fire and we collected all the ashes from the burning, all of the smoke particles that normally would go up the chimney, but if we collected them, and all the water vapor that was released during the burning, and we found the mass of all those substances afterwards, it would equal the mass before. And same thing with physical changes. Obviously, if you found the mass of a piece of wood and you cut it in half, it would not change the mass. Okay? So properties are usually adjectives. They're words that describe things. Like the size of something is large, it's rough. Okay, and remember, there's lots of them. Pretty much every word is an adjective. Okay, flammable is an adjective. It describes a word. Okay, conservation of mass. It says matter or mass is not lost or gained, created or destroyed. This applies to both physical and chemical changes. As I said, you may burn the wood, but the mass of all the atoms in the smoke, the ashes, and all the water vapor that came out of the wood have the same mass as the wood before burning. Okay. And I wanted you to take and put some of these physical and chemical changes in a graphic order. Physical properties describe a substance. No new substance is created. They can be detected with our five senses or by measuring. Okay. Chemical properties describe how a substance will react. A chemical property will always produce a new substance. We see properties, we can't just observe them by looking at something. We actually have to test them, or somebody else had to test them. So, I mean, in the past, we know that, like, for example, wood, it's been tested. Somebody else did it. We know. Okay. But if it was something new and you just took a look at it, you might not know. So you or somebody else has to test it for us to be sure. Okay. Which means we can't tell just by using our five senses. We can't just look at it and know for sure what it's going to do. Okay. And what physical and chemical have in common is they can both be used to separate mixtures or to separate compounds from atoms, so they can be used to separate things. It can be used to identify something. I'm going to talk about that in a second. They both follow the law of conservation of mass. And they can change a property, like changing color. So when the iron rusts, it turns brown. If you paint something, it changes color. Okay. Now, in real life, okay, what does this all have to do with real life? Well, people separate stuff all the time. Okay. Like, for example, when they go and dig iron up out of the ground, it's mixed in with dirt. So first, they want to get it's called iron ore, separated from just the dirt. Then they need to. The iron ore is basically rust, is what we find in nature, so it's iron oxide. So they need to use chemical separation to break the iron apart from the oxygen. So they end up with just the pure iron, just so that it can be used to make things that we use, like car parts. Okay. Now, in real life, the police use this stuff all the time. Okay. They might find something at a crime scene, and based on its physical properties, they know what it is. Like, if it's a murder weapon, it's physical properties, they know what it is. But then they may have to use like chemical properties to identify other things. So for example, the blood on the knife, they may have to do a DNA test and do some chemical analysis to find out who it belonged to, okay? Or for example, suppose somebody was speeding down the freeway and when the officer pulls him over, he notices that this person has white powder on their clothing. And driving kind of funny. So, with probable cause, he asks him to open a trunk and receives bags of white powder. Doing something illegal. But this is Luigi, the chef. And he says, well, this is special flour that I'm taking to Richmond to make my bread. Based on the physical properties of just seeing white powder in the trunk, does the officer know for sure what that substance is? No. Okay, so based on the physical properties of its white and its powder, like maybe Luigi's telling the truth, and maybe he's not telling the truth. So they would have to use both physical and chemical properties to identify the substance if they end up having to go to court. Okay, so the stuff would go back to the crime lab and they would do some chemical tests on it, or the officer might have the test kit with him. But either way, they're going to do some chemical tests on the substances to find out if Luigi is actually telling the truth. Okay, well, I said today's lesson was going to be kind of short, so I hope you're all having a great day, and we'll see you next time. Don't forget, you need to take the pre-test.